All right, today we're going to dive into a really fascinating new idea called nested learning. And this isn't just another small tweak. We're talking about a completely fresh approach, one that could finally let our AIs learn continuously, for their entire lifespan without forgetting everything they just learned. It's a huge deal.
But let's start with a thought experiment. What if the most powerful AI we have, what if it just couldn't form any new long-term memories? I mean, what if everything new it learned was just gone, almost as soon as it saw it? Well, here's the thing. That's not a hypothetical. That's pretty much the reality for today's models.
So the technical term for this problem is, well, it's pretty dramatic. It's called catastrophic forgetting, and it's exactly what it sounds like. When you try to teach a standard AI something new, it basically just overwrites and forgets what it learned before. The researchers behind this have this incredible analogy for it. It's like a form of anterograde amnesia, the kind where someone can't form new long-term memories. And that's exactly what's happening here. It means our AIs are basically trapped in the past, stuck with their initial training and whatever they can cram into their short-term memory.
So yeah, let's really get into this memory problem. Because it's not some minor bug we can just patch later. It is a fundamental wall that's stopping us from building truly intelligent, adaptable AI. Just think about it for a second. The large language models we use every day, they're incredibly powerful, sure, but their knowledge is essentially frozen in time. The second their pre-training stops, that's it. Their understanding of the world is locked. They can't truly grow, they can't evolve, they can't absorb new long-term knowledge from experience. They're just static snapshots of the past.
So, if our current way of doing things has kind of hit a dead end, where do we even look for inspiration? I mean, what's the best example out there of a system that has absolutely mastered the art of learning for a lifetime?
Well, the answer probably won't surprise you. It's the one system that's been perfecting this for millions of years. The human brain. It is the absolute gold standard for continuously adapting and learning new things without just wiping the hard drive clean every time.
And the brain strategy here is it's fascinating. It really boils down to two main ideas. First, you've got neuroplasticity, which is just a fancy way of saying the brain can literally rewire itself. But the second part, and this is absolutely crucial, is how it uses multi-frequency brainwaves. So think of it like this. Some parts of your brain are learning and reacting super fast in real time. Those are the high-frequency cycles. But at the exact same time, other parts are taking that information and integrating it much more slowly on these longer cycles to build up those stable long-term memories. It's this incredible symphony of different learning speeds all happening at once that makes it work.
And when you put them side by side, the difference is just stark. On one hand, you've got the human brain, this dynamic, living thing with all these different parts updating at different speeds simultaneously. And on the other hand, you've got our current AI models. They're static, they have one single, massive, slow update process called pre-training, and that's it. Game over.
This quote from the researchers really just hits the nail on the head. For decades, the way we've built AI is we design the structure, the architecture, and then, completely separately, we design the process for training it, the optimization algorithm. And it turns out this separation, this wall between the two, has been holding us back the whole time.
And that single insight that we have got to stop treating the architecture and the training as two different problems. That's what leads us to this breakthrough. It's a whole new paradigm that finally merges those two worlds into one idea, nested learning.
This visual right here is the heart of it. On the left, that's the old way of thinking about AI training, just one big flat process. But nested learning, on the right, it completely reframes the picture. It says, hey, wait a minute. An AI model isn't one learning problem. It's actually a stack of different learning problems, all nested inside each other. And each of these levels or layers gets its own update speed. Some learn fast, some learn slow, just like the brain.
So to put it formally, nested learning is a paradigm that sees an AI model not as one thing, but as a whole system of interconnected optimization problems. Each level in this system learns at a different frequency, from a different flow of information, kind of like those brainwaves we were talking about. It makes the model's structure and its training process two sides of the very same coin.
Now, this isn't just some cool theory on a whiteboard. The researchers actually went and built a proof of concept AI based on these very principles. They call it HOPE.
And this comparison just shows you how different it is. On the right, you've got your standard transformer model. Pretty straightforward. But then you look at HOPE on the left. It's got this self-modifying core and then this whole stack of networks. And you can see they each have their own update frequency, going from high to low. This isn't just a conceptual diagram. This is literally the architecture inspired by the nested learning idea.
So what's the magic here? What makes Hope tick? Well, it comes down to two big innovations. First, at its core, it has what they call self-modifying titans. This is basically a part of the AI that learns how to learn better over time. It can actually optimize its own internal rules. And second is the continuum memory system, which is that stack of memory modules we just saw. It creates this whole spectrum of memory, all the way from fleeting short-term thoughts to deep, stable, long-term knowledge.
Okay, so the architecture is cool, the theory is cool, but does it actually work? Let's get to the results and see how Hope stacks up against what's already out there.
First up, language modeling. Now, this chart shows something called perplexity. All you need to know is that it measures how surprised a model is by new text, so lower is always better. And as you can see, Hope consistently scores lower than the baseline models. That means it has a deeper, more intuitive grasp of language.
Next, they threw a really brutal memory test at it called needle in a haystack. This basically checks if a model can find one tiny, specific fact buried in a massive document. Here, a higher score is better. And look at that. Hope clearly outperforms other very advanced models, which is solid proof of its superior memory system.
And if we zoom out and look at a whole range of different tasks, from language stuff to common sense reasoning, the story stays the same. This table shows that across the board, Hope is right up there, delivering top-tier performance. It really shows off how powerful and flexible this nested learning design is.
So the results are really, really impressive. But what does it all mean for the big picture? Where does this new path actually take us?
Well, the way the researchers put it, what they've found here is way bigger than just one new, clever architecture.
No, it's a fundamentally new dimension for designing AI systems. Think about it. For years, we've only had two ways to scale AI: make them wider or make them deeper. That's it. But nested learning, this gives us a third axis to play with, a temporal axis, if you will, the number of learning levels and their speeds. It is a completely new way to build complexity and power into these systems.
Which brings us right back to where we started. By finally taking inspiration from the multi-speed, always changing architecture of the human brain, nested learning might just be the key. This could be the breakthrough that finally lets us build an AI that can learn, adapt, and grow for its entire lifetime.